In previous videos, we talked about the lens refractive index distribution. We talked about the geometrical aspect of the refractive index. We talked about the thickness of the refractive index. So right now, in this video, we want to talk about lens equivalent refractive index. So what does it mean? Let's take a look at the meaning of equivalent refractive index. So the real lens refractive index is like this. At the center, we have higher refractive index, and when you go to the edges, the refractive index decreases. So right now, let's say we want to simplify this optical model for ourselves. We can have, an imaginary equivalent refractive index for the lens, for the whole lens geometry that has the same thickness, like the real lens, the same radii of curvatures, for posterior and for anterior and posterior surface, the same radii of curvature. Here is the anterior, here is the posterior, the same radii of curvature, but has a uniform refractive index. So it means that opposite of the real lens, that the refractive index has gradient. Now we want to consider one number for the refractive index of the lens. And we should select that refractive index in a way that gives us the same lens power, because we don't want to change our optical system. So in this case, the equivalent refractive index is 1.42. So we can imagine in our brain that we have a lens with the same geometry. If we replace it with a bulk material with 1.42 refractive index, that can provide us the same amount of optical power. So we should be, this is amazing that the equivalent refractive index is slightly higher than the maximum value of the refractive, of the real lens refractive index distribution that in another video that I explained it, that at the center we have high values and at the edge we have lower. So the maximum value of the refractive index over there is 1.41, and the equivalent refractive index is slightly higher than this one. So, but we can actually consider the lens with one bulk material with 1.42 equivalent refractive index. Thank you very much. And here is the reference that I use for